Today's module is time series analysis using R as the tool of choice. So we are going to learn how to analyze and forecast on the basis of time series data using the various algorithms available in R. The topics that we are going to cover, first, of course, we need to learn what time series is. We are going to look at a couple examples in real life as to what a time series looks like. Then we are going to take an example of time series and dissect it to see the various components of time series. And we need to look at the various components of time series because the forecasting algorithms optimizes the components separately, and we need to know which algorithm to use in case certain components are present or absent. And the last part, which perhaps we are all really looking forward to, is we are going to learn how to forecast on the basis of time series data. And that would involve some preliminary analysis of time series. And next, last but not least, actually using the algorithms in R to do the forecasting. And once we have built the model to forecast, as in any modeling exercise, we need to validate the model. So the first thing we need to learn is, what is a time series? Well, the name itself implies a time series is a series of data collected over time. So it's data collected at specific time points. For example, say at the end of each day, end of each week, each month, each quarter, each year, etc., etc. But the nuances that we should be aware of is that this data should be collected consistently and should be well defined. That is, say for example, monthly sales data of eBay. So this data is collected at the end of each month. It's not that you collect this data 1 month and then do not collect it for 5 to 6 months and then again start collecting it. No. I mean, the monthly sales data of eBay keeps flowing every month and it's summarized by someone and stays in the data warehouse. So this data, the monthly sales data of eBay, is a consistently and regularly collected data, and so it can be called a time series data. So if the data is not collected consistently or regularly, we cannot use that time series to do our forecasting. Couple other examples of time series to start with, like consumer prices of commodities that we buy and sell, annual bank deposits, and these are pretty common examples of time series data. To have a closer look of eBay sales data, this is what it looks like. So these are the sales dollars of eBay collected at the end of each month. And on this slide, I am showing you the data for 1 year, 2012, starting from January through December. Whenever we get a time series data, the first thing to do is plot it. And if you plot the eBay data, this is how it looks like. So what are the features that we should notice? You should notice that starting from October, the sales figures go up, and this is how it is almost every year. Why? Because October, November, December, these are the holiday months. People are on a buying spree. They buy a lot on eBay, and eBay makes a lot of money. And after they buy a lot, most people are broke, and so in January the sales dips down. So this phenomenon, and we are going to study this in more details later, this phenomenon is what is known as seasonality. So every holiday season, the sales peaks, and right after that, the sales dip. And you can also see that around June and July, the sales are a little high because at the end of summer, people again want to buy stuff. They go on vacations, they buy stuff, and eBay makes more money than the rest of the year. Moving on, like few other examples of time series. First, stock prices. Stock prices are collected every day at the end of each day. So it's a regularly collected, consistently collected data, and it comprises a time series based on which we can forecast future stock prices for the next day, for the next week, and so on and so forth. Retail prices, like say the price of coffee that you buy and so love to drink. Well, retail prices collected at the end of each month would definitely comprise a time series because it's a well-defined, consistently, regularly collected data. Gold prices collected at the end of each year. Boolean prices, yearly Boolean prices comprise time series data. Balance or outstanding loan amounts at a consumer bank. These both of them, if they're collected monthly and if they're collected regularly, which is the way it's usually done in the banks, definitely comprises time series data. And based on each of these time series data that we have seen, we can forecast the trends, future amounts or future variations of these time series data. And why is that important? One last example of time series data is like passengers of an airlines company and the data collected maybe at the end of each day or each week. And again, our regularly consistently collected data like this can definitely be termed time series data. Now, so the point I was trying to cut across is that why are such time series data useful? Time series data is useful because time is money. And we want to know like what each of these data would look like in the future, in the next 6 months or in the next 6 days or in the next 6 weeks. And based on that, the business leaders can take their decisions. So time series data is important to forecast for the future based on the historical data. And here again, like if we have a look at the eBay sales data, we had data till December 2012. And if we do forecasting based on this time series data that's available, we can get to know the sales figures for the next 6 months maybe, and that would help us to take a whole bunch of business decisions. Now, one pertinent question. Today we are learning about time series forecasting, but I'm sure you guys are already totally familiar with regression modeling. We have the data from 2012. We want to predict the data for 2013. Then why not use regression modeling? The reason perhaps we will not use regression modeling in our example as of now is because regression modeling requires explanatory variables. To predict the sales of 2013, we would perhaps need other variables like price, location, etc., etc. But for time series forecasting, all we need are the sales figures, the sales dollar amounts for 2012, and just based on that one variable, we can predict the sales dollars for 2013. So when we only have one variable, most likely our method of choice to forecast would be time series forecasting.